Hey everyone, welcome back to the AP Pre-Calc lesson videos. This is the Unit 1A exam review that I'm going to be going over today. Let's get right into it. All right, so first we're going to be talking about the question breakdown. So the first thing I'm going to do is the day of the exam, I'm going to collect two things. The first thing is going to be your bell ringers, and then the next thing is going to be your exam review, what we're going over. Obviously, because you'll have all the answers, these two are just going to be graded on completion, right? Did you do every problem? Did you not skip any problems? If you did every problem, you're going to get a 10 out of 10. So pretty easy grade boosters there. Let's talk about the Unit 1A exam. So this is going to be all no calculator. So most of my exams will be no calculator. There may be a few calculator sections, but for the most part, no calculator. And then this is also going to be covering 1.1 to 1.6. So those are going to be the only topics that are tested. Nothing from the summer assignment. That was all pre-calculus. And so just 1.1 to 1.6, even the stuff that was on the quiz though. So you got to go back and study that. All right, so the test will be out of 102 points, but I'll take whatever you get. Let's say you get like a 90 out of 102 and just take it out of 100. So there's 2 points of like a grade booster there. This is wrong. This should say 12 multiple choice questions. So you're going to have 12 multiple choice questions for 5 points each. This is going to be 60 points or 60% of your total grade. You're going to have 2 free response questions. The first one is 8 points for free response number 1. And then this is going to be 8% of your grade. This is going to be that where I give you the 5 coordinates, and then you have to tell me whether it's positive or increasing or decreasing and negative, and then talk about the concavity. That's that short answer question. Short answer question number 2 is a little longer. It has 8 different parts. That's a free response. There's one of those, and that's going to be 32%, right? And so I will say these parts do not build on top of each other. They're very separate, different questions. And so if you miss the first part, you could easily get all the other 7 parts correct. Missing the first part won't take away from parts 2 through 7. And then at the end, one really difficult extra credit question for 2 points. This one is one that will really make you think. So let's get into how can I best prepare for this exam. The first one is, and this is the most important, do every problem on the exam review. I took your exam that I already wrote and I created the exam review with very similar questions, right? Obviously, it's going to be different numbers, different equations, maybe different graphs, but like the general ideas of the questions will be the same. So if you see a topic that's not necessarily tested on the exam review, more than likely it will not be tested on the exam. So just be aware of that. Like if I don't ask anything about, let's see, maybe how to find imaginary solutions like we did in class and it's not on the exam review, then you won't need to know how to find imaginary solutions on the exam. The next thing is do the bell ringers. These are pretty important. These are all what I deem to be good exam questions, so very similar to questions you'll see on the exam. The next thing is obviously just go back through all the homework and in-class examples. You always have solutions to the homework because I will post them online come exam time. I will also, you can always look through for the in-class examples at my YouTube videos, the other ones on this page, and look at how I solve the in-class examples if you were ever stuck or if I went too fast during class. Then, number 4, use the YouTube videos or come into office hours if you need help. I'm always willing and able to answer any questions. The main thing is, though, if you are gone for a day, I would prefer for you to watch the YouTube video first and then come into office hours with questions. But obviously, if you just have questions on the exam review or need help, right, come to my office hours whenever, please. All right, so let's just get into the exam review. I'm going to go through this question by question, and then we will just solve them together. So the first one is a polynomial function is given by ax to the power of n, where a and n are integers, and n is a positive number that's greater than 1. If the n behavior is given by the following limit statements, which of the following could be the values of a and n? So let's draw these limit statements out. So as x approaches negative infinity, this is going to approach negative infinity. So this is going to behave like this. So that's that arrow there. And then as x approaches positive infinity, this also goes to negative infinity. So that's going to behave like this. So that end behavior is going to mimic y equals negative x squared out of our four main functions that we talked about in 1.6. All right, and so what you want to do here is remember the key questions that we want to ask ourselves when determining end behavior is one, is the leading coefficient positive or negative? And then is the exponent or degree even, that should be positive, even or odd? And in this case, y equals x squared, it's a negative leading coefficient and an even degree. So we're going to want that, right? We want a of n to be a negative number, in which case this should be not positive 3, but it should be negative 3. So we can eliminate c and d. And then we also want n, our exponent, to be an even number. So n should not be 5, n should be 4. So b should be our correct answer there. All right, the table above shows values of the even function f at selected values of x. What is the value of a? So remember, if we have a point x comma y on an even function, then we know the point negative x comma y will also be there, which means because an even function is symmetrical across the y-axis, if you have x here and then negative x, they're going to have the same y value at both points. So here we are looking at a comma 5, and let's see, what could we kind of compare it to? We could compare it to something with the same y value. And so I see another point, negative 4 comma 5. So we can take the opposite of negative 4 to get a equals positive 4, and that should be our answer there. All right, number 3, the figure shows a graph of function f. It is known that the maximum occurs at d, right? So that's going to be at the very top. And the only point of inflection is point C. Where's the rate of change the greatest? So here we want to look at where's the slope at which of these points is the greatest. And so A should be a negative slope. B and C should both be positive. And D should be 0, right? Because it's flat and it's exactly at the top. So now what we want to do here is see when it says which is the greatest, you want to look at the two positives, B and C. And how can we tell which one's greater? You kind of want to guesstimate the slopes, right? So if we have an upward slope and you have one here and one here, which one's going to be steeper? It's probably going to be C because it's steeper in the positive direction. So C is going to be our answer for 3. I will say these are like going to be your multiple choice questions on the exam, but on the exam review, I like to take your multiple choice questions and make them more short answer if I can. All right, 4, this was actually one of your bell ringers, I think. Shows a quartic polynomial. How many points of inflection does the graph have? Here you want to identify any peaks or valleys. I see 3 here. And then halfway in between will typically be a point of inflection. 1 point of inflection only, so there should be 2 here. Notice how these do not have any points of inflection, so not between endpoints, only between peaks and valleys, right? Very important there. So 2 is the correct answer. 5. The graph of h of x is shown above. Based on this graph, at what values of x does the rate of change go from negative to positive? So remember, negative rate of change is just a decreasing function because it's a negative slope, and a positive rate of change is just an increasing function. So where does it go from negative to positive? That's going to be at its valleys, right? At its local minimums. So let's take a look here. I see 1 local minimum and 2 local minimums. So these values of x's should be negative 0.593 and x equals 2. And so that should be our answer there, where the rate of change goes from negative to positive. Number 6, the graph polynomial function h is shown above. It is known that x equals negative 2, shown on the graph, so I'll mark that there. X equals 1, shown on the graph. And then these two complex numbers are zeros of h. What's the least possible degree? So very similar, like an example we did in class that I said would be tested. So this concept will be tested. Here, we want to find the least possible degree. So first, let's start with the zeros identifiable on the graph. We have x equals -2 and x equals +1. -2 is going to have a multiplicity of an even number because it bounces off. The lowest even number that we can think of is 2. It technically could be 4, 6, or 8. There's no way of us knowing, but we want to go with the least possible number of the degree, which means the lowest possible multiplicity for each zero that we can find. But we at least have to double count it because it bounces off. At x equals 1, it crosses straight through. So here we could just say the multiplicity is 1. Those are our two zeros on the graph, and then we know x equals 2 plus 3i, x equals 2 minus 3i will also be zeros. And unless it's stated otherwise, we can assume that these will also have a multiplicity of 1. Just know that imaginary roots come in pairs. So in this case, 2 plus 3i and 2 minus 3i would be zeros of this function here. And then we have x equals 1 plus 2i and x equals 1 minus 2i as our two other zeros of our function here. And so here now, these are all the zeros we can find, so we want to add these up to get our degree. So 2, 3, 4, 5, 6, 7. So 7 should be our degree here. All right, the graph of the polynomial function p is shown above. Which of the following could be an expression for p? What we have here is we want to do kind of the same thing, find the zeros. So the only zeros here are, we see an x, we see a x plus 2, and an x minus 3. So we can assume safely that this is going to be 0. This is going to be x equals -2. And then this is going to be x equals +3, because those are zeros from our possible linear factors. And those are the only linear factors in all four answers, right? Now we know the 0 at -2 should be odd. The multiplicity should be odd because it passes straight through. So at -2, this should be an odd multiplicity. All of those pass the check. Now at 0 and 3, though, because they bounce off the x-axis, the multiplicity should be even. And this is what's tough, is now because it's even, they both have to be raised to an exponent of 2. And so A, this 0 is not, and this 0 is not, and then this one's not as well. So A and B are off, but now we have C and D. And what's the difference between them? One has a negative out in front, and one has a positive one assumed to be out in front. And so which one is correct? This is really tricky, but what we want to do here now is look at the end behavior of the function, which the end behavior is going to mimic y equals -x because of these tails there, right? So we now know it's going to behave like y equals -x, which means it should have a negative leading coefficient and an odd degree. If we take a look here, if you FOIL these out, remember one trick that I have is when you're FOILing out a bunch of these linear factors together, you can cancel out the smaller terms, and you're really only doing -x squared times x squared, and then here you're doing x squared times x squared to find our leading term. So this should be -x to the fifth, and this should be +x to the fifth. We want a negative leading coefficient to mimic this end behavior, so C should be our answer there. Number 8, the figure shows a graph of function h with 4 labeled points. It is known that a relative maximum occurs at C. Where is the average rate of change the least? So let's take a look, right? A is between A and C, so that's our slope there. B is between B and C. So this is A, this is going to be B. C is between B and D. And then D is between C and D. So if we take a look at A, B, C, and D, our average rate of change, B is positive, and the other three are negative. So we're looking for the lowest number, so we can eliminate B right off the bat, right? So get rid of that. Now we have A, C, and D, and we want to find the lowest slope, which means because they're all negative, we want to find the steepest negative slope, right? Because a slope of -8 is going to be super steep, and a slope of -1/2 is not going to be as steep, but this is the lower number. So the steepest one of those three lines should be D. And here you don't even really need to find exact points and do the slope formula. You can tell graphically from this question though. So D should be our correct answer there. All right, number 9. Let the function g of x equal -x to the fourth. Which of the following is correct about the end behavior? So let's take a look. This has a negative leading coefficient and an even degree. So this is going to behave like y equals -x squared. So it should behave like this. If we write our two limit statements, this should be the limit as x approaches -infinity, and then our other one would be the limit as x approaches positive infinity of g of x equals, and these are both going down, so they're both going to -infinity. So A should be our correct answer there. 10. The following values is shown. Which of the following describes the extreme values? Does it have a local or absolute minimum, or both, or neither? So here, let's take a look. I see 1, 2 local minimums. So these two are going to be local minimums, which is either going to be, remember, local extrema is either going to be a min or a peak, or for minimums, they should be valleys, or if they're the bottom of a restricted domain endpoint. But here, this is the top, so this would technically be a local max. So that doesn't count, but we still have local minimums, though. So we can eliminate C and D, saying it doesn't have a local minimum. Now we want to see if it has an absolute minimum. And so, does this have a lowest point on the graph? The answer is yes, it does. The lowest point is right here at, this should be at -4 at x equals 2, should be the absolute minimum, because there's no point that goes lower than that. So this should be, A. A is our correct answer here. It has both a local and an absolute minimum. Number 11, values of the polynomial function g of x are shown in the table above. Which of the following statements is true? So here we're talking about concavity. All 4 answers address concavity. So let's see if this graph is concave up or concave down. So to determine this, we only want to find the first difference, the average rate of change. This is -4, -3, -2. And see how these are changing. So we're going from -4 to -2. So we are increasing in numerical value. So this is going to be concave up. And this is because the average rates of change, right, that first difference, are positive. They aren't even positive, so it can't be A. It is because the rate of change is increasing. And remember from 1.1, right? If the rate of change is increasing, then the graph is concave up. And so B is a great example of that. All right, 12, let g of x equal x cubed, which is an odd function only. Which of the following statements about g is correct? So for this one, a little tricky. What you're going to want to do is basically just remember the rule for odd functions. So the rule for odd functions is negative f of x equals f of negative x. And this is what we covered in class. And this is just something that if you can't derive it the way I did it in class, you're just going to have to remember that rule. Remember the rule for even functions is just f of x equals f of negative x. But these are important for this. So this one should be B, should be your correct answer there. All right, number 1, the graph is shown with 5 points. We're looking from F to G, so make sure that you understand that this is the curve you're looking at. Which of the following is true? About H, is it positive or negative? So to determine if it's positive or negative, you want to look at the y coordinates. And so here, we're going from -1 all the way down to -7, so we're going to be dealing in the negatives. So it's either going to be C or D, and then this function here is going down, so this should be decreasing. So D is your correct answer for A. For part B, a lot of people missed this one, which I was a little shocked by in the quiz. Determine the concavity and determine whether the rate of change is increasing or decreasing. You don't need to write that much, and there's a lot of wording that people had that was really unique that was also marked as incorrect. So this is the wording that you want. This graph, or this portion of the graph, is clearly concave down, and so we're just going to write, literally write concave down, and then write rate of change, and if it's concave down is, and it's either going to be increasing or decreasing. It's not going to be positive or negative or constant or linear. No, it's literally just one of those two words. In this case, the rate of change is decreasing. And if you have this, you would get full credit, right? So make sure, though, you specify what is decreasing. In this case, the rate of change. If you just say the word decreasing and concave down, that would be marked as wrong. So really just make sure that you fully understand how to answer this question. I want every single part of this. So talk about the concavity, talk about how the rate of change is changing, but that's all you need though. All right, part 2. This example is very important. I will say pay close attention to whether they're asking about F or whether they're asking about G, because they're only going to be asking about one of those questions or one of those functions for each question. Right, so here, based on the table, which of the following function types best models function F? Linear, quadratic, cubic, or quartic? So this one, if we take a look, and I'm just going to redraw this table. -5, 1, 3, 1, -5 here, and then we can work this out. So this should be +6, +4, -2, -6 there. Sorry, this should be +2. Whoops. Let me erase that and fix that. So this should be +2. And now this should be -4, -4, -4. So because our second differences are the same, this is going to be quadratic. So that's all you need for part A. Part B, refer to your answer in part A. So obviously it's tough because this is a new slide. But remember, our second difference was the same, right? It was -4. So we're going to talk about that here. The first thing you want to say is over equally spaced inputs, not over inputs that are constant. A lot of people made that mistake on the quiz. If you say the inputs are constant, that's saying that these are all the same number, and they're clearly not. So say that they're equally spaced. Do not say they are constant. So over equally spaced inputs, the outputs have a constant second difference, and this is because it's quadratic, of -4, and that's it. You could also say over equally spaced inputs, the average rate of change of the outputs behave linearly by going down by 4. You could say that. That would also be acceptable. If it was cubic or quartic, then just say basically this statement, but then talk about what the third or fourth difference is instead of the second difference or the first difference if it was linear. All right? C, determine the concavity. We kind of did this in a multiple choice question, but let's do more practice. So here we take a look. +6, +2, -2, -6. Whoops. And so this is going from 6 to 2 to -2 to -6. So this is decreasing. So here I would want you to say it is concave down because the rate of change is decreasing. And that should be your answer. Okay, Here we go. Part D, determine the average rate of change over the interval from -1 to 2. Here, you're literally finding your two coordinates, which have an x value at your two endpoints, -1 and +2. Find your corresponding y coordinates, so 1 and -5, and then plug them into the slope formula. You should get -6 over 2 plus 1, which is 3. So here, our slope should be -2. You have to show your work. If you do not, it will be marked as incorrect. All right, here we go. Based on the table, determine if it's even, odd, or neither. Show your work and your reasoning. And so here I would say, because f of 1 equals f of -1, which is both equal to +1, and f of 2 equals f of -2, which both equals -5. This function is even, because even functions have the property f of x equals f of -x. All right, so basically what I would be looking for in a short answer question is, if it's even or odd, give me specific examples that prove that it's even or odd, or that disprove that it's even or odd. I would like to see that you know this rule or can apply it like this. So either one of these, if you have like this or this, that would be fine. But just explain either verbally or with numbers and examples why the function is even, why the function could be odd or neither on your exam. All right, so now we want to shift our focus from f of x, that table, and we want to shift our focus now to g of x. And this is the equation, -x³ minus x squared plus 6x, and we want to find the leading term, degree, and leading coefficient. So our leading term is going to be our term with the highest exponent, so -x³. Our degree is going to be that highest exponent, so 3, and our leading coefficient should be our number in front of that x term, which is an implied -1 there. Now we want to find all the values of x for which g of x equals 0, that -x³ minus x squared plus 6x, and we want to find the zeros, roots, solutions, any of those would work, or indicate that there's no such zeros for this equation, and then we want to indicate the multiplicity of each zero. So here I'm going to factor out not just an x, so I'm going to factor out a -x. And the reason why I'm factoring out -x is so the trinomial that I'm going to be left with is going to have a positive leading coefficient, because you're going to need to factor it. So if we take out a -x, we're left with x squared plus x minus 6. And then we can factor a little more to get x plus 3, x minus 2. And so here, our first zero, this is just at x equals 0. This one is at x equals -3, and then x equals +2 there. Once we have this, the degree on each linear factor is 1. That exponent is implied to be 1. So our multiplicity should be 1 for each of these. So that is how I would want your answer formatted. If you have this, you should get full marks on the test. All right, the next one is determine the end behavior of this function as x increases without bounds. This means as x goes to positive infinity. If it says as x decreases, that would mean as x goes to negative infinity is as x decreases without bound. But we don't have to worry about that. So let's write our limit statement. The limit as x approaches positive infinity of, remember to have the correct function. If you write f of x, you will get it wrong. So make sure you have g of x. And then here, our leading term is -x³. So that's going to mimic -x. So like this. And this is going to be, as we go to the right forever, we go down. So -infinity. And this should be our answer. You have that, you get all 4 points. And so that's pretty much it for the exam review. Let me know if you have any other questions. Please come into office hours if you do. I'd be happy to help you, but this is probably going to be your best resource for studying for the exam. Best of luck on the exam, and I will see you guys later. Thanks.